Have you ever wondered if someone is watching us from space? It sounds like science fiction, but the truth is even more fascinating. For decades, countries have been using satellites and other space technology to gather information on each other. It's called space espionage. You might think of spies as characters in movies, wearing disguises and carrying secret codes. But in the world of space, the spies are sophisticated satellites equipped with powerful cameras and sensors. These high-tech marvels orbit Earth, silently observing and collecting valuable data from afar. Space espionage dates back to the beginning of the space age itself. The Cold War, a period of intense rivalry between the United States and the Soviet Union, saw the rise of this new form of intelligence gathering. Both superpowers were eager to keep tabs on each other's military activities and technological advancements. The launch of Sputnik, the first artificial satellite by the Soviet Union in 1957, sent shockwaves around the world. It was a monumental achievement that demonstrated the Soviet Union's advanced technological capabilities and marked a significant milestone in human history. This event marked the beginning of the space race, a fierce competition between the United States and the Soviet Union for dominance in space exploration. Both nations poured vast resources into their space programs, striving to outdo each other in a bid for technological and ideological superiority. But it also signaled a new era of espionage. The ability to launch satellites into space opened up unprecedented opportunities for surveillance and intelligence gathering, changing the nature of espionage forever. The US was caught off guard by Sputnik's launch. The American public and government were shocked and concerned about the implications of Soviet space capabilities. They realized the Soviets could now spy on them from space. This realization led to a sense of urgency and a renewed focus on developing their own space and surveillance technologies. This realization fueled the development of the Corona program, America's first dedicated spy satellite program. The Corona satellites were designed to gather intelligence from orbit, providing the US with a new tool in the Cold War. These satellites carried high-resolution cameras and could take detailed photographs from orbit, capturing images that were previously impossible to obtain. The images captured by Corona and other early spy satellites provided crucial intelligence during the Cold War. They offered insights into Soviet activities and capabilities that were invaluable to US policymakers and military planners. They helped to verify arms control treaties, monitor military buildups, and even track the movements of Soviet ships and submarines. This intelligence was essential for maintaining a strategic balance and preventing misunderstandings that could lead to conflict. The information gathered from space played a significant role in shaping global politics and preventing conflict. It underscored the importance of space as a new frontier for both exploration and security, influencing international relations for decades to come. Today, space espionage is more sophisticated than ever. Nations utilize a wide array of satellites, each designed for specific intelligence-gathering tasks. Some satellites are equipped with high-resolution cameras capable of identifying objects as small as a car from hundreds of miles away. Other satellites use radar technology to see through clouds and even penetrate the ground, revealing underground facilities. Still others intercept electronic signals like radio communications and radar emissions, providing valuable insights into a country's military capabilities and intentions. The data collected by these spy satellites is analyzed by intelligence agencies around the world. This information is used for a variety of purposes, including monitoring military activities, tracking terrorist groups, and assessing the environmental health of our planet. Space espionage has become an integral part of global security in the 21st century. Section 4. Secret Agents in Orbit Unveiling Classified Missions. While much of what goes on in space espionage remains classified, there have been some notable missions and programs that have come to light. These missions often involve advanced technology and strategic planning, showcasing the incredible lengths to which nations will go to gather intelligence from space. One such example is the American Lacrosse series of satellites. These satellites have been instrumental in providing high-resolution imagery and intelligence data. These satellites are equipped with synthetic aperture radar, allowing them to see through clouds and even penetrate the ground to a certain extent. This capability makes them invaluable for both military and civilian applications. Another example is the Israeli OFEC series, which is believed to be focused on intelligence gathering in the Middle East. These satellites provide critical data that supports national security and strategic operations. The details of their capabilities are shrouded in secrecy, but their existence highlights the global nature of space espionage. Nations around the world are investing heavily in these technologies to maintain a strategic edge. These are just a few examples of the many classified missions that are currently operating in space. The sheer number of these missions underscores the importance of space as a new frontier for intelligence and surveillance. These programs, shrouded in secrecy, represent the cutting edge of space technology and the lengths to which nations are willing to go to secure their interests in the cosmos. As technology continues to advance, the scope and capabilities of these missions are likely to expand even further. Section 5. Beyond the telescope, the technology of space spying. The technology behind space espionage is constantly evolving. Satellites are becoming smaller, more maneuverable, and equipped with even more advanced sensors. For example, some satellites now use hyperspectral imaging, which can identify the chemical composition of objects on the ground. This technology can be used to detect everything from mineral deposits to chemical weapons. Another emerging technology is space-based lasers, which could be used to blind enemy satellites or even destroy them entirely. As technology advances, so too does the potential for space espionage. The future of intelligence gathering might involve even more sophisticated satellites, capable of tasks we can only imagine today. This constant development raises important questions about the future of warfare, privacy, and international relations. Section 6. The future of espionage, a new space age. As we venture further into the 21st century, the future of space espionage is likely to be shaped by several key trends. These trends are not just technological but also geopolitical, reflecting the complex interplay between nations and private entities in the new space race. One significant development is the increasing accessibility of space. This accessibility is driven by advancements in technology and reductions in the cost of launching payloads into orbit. With the rise of private space companies, it's becoming easier and more affordable for nations and even private organizations to launch their own satellites. This shift is democratizing space, allowing more players to enter the field. This democratization of space could lead to a proliferation of spy satellites, making it more difficult to monitor and regulate space-based intelligence gathering. The sheer number of satellites could overwhelm existing tracking systems. Another important trend is the increasing sophistication of artificial intelligence. AI is transforming how data is processed and analyzed, making it possible to extract valuable insights from vast datasets. AI is already being used to analyze the vast amounts of data collected by spy satellites. This technology can identify patterns and anomalies that would be impossible for humans to detect on their own. In the future, AI could play an even greater role in space espionage, potentially enabling autonomous satellites that can make their own decisions about what to observe and when to collect data. These satellites could operate independently, without human intervention. This raises concerns about the potential for AI-driven escalation of conflict and the need for international cooperation to establish ethical guidelines for space-based AI. As we move forward, it will be crucial to balance technological advancements with responsible governance. Section 7. Ethical constellations, balancing security and privacy. The increasing prevalence of space espionage raises important ethical questions about the balance between national security and individual privacy. As technology advances and surveillance from space becomes more powerful, it's crucial to establish international norms and regulations to prevent the misuse of this technology. Some experts argue that there should be international treaties limiting the capabilities of spy satellites or establishing no-spy zones in space. Others believe that such restrictions would be difficult to enforce and that the focus should be on transparency and accountability in space activities. Ultimately, the future of space espionage will depend on the choices we make today. It's essential to engage in thoughtful dialogue and international cooperation to ensure that space remains a realm of peaceful exploration and scientific discovery, even as we grapple with the complex ethical challenges posed by this hidden aspect of the cosmos.